for our computer engineering project. We were given the challenge of developing an embedded system using the Odroid and several other components of choice. We decided to develop a smart cat feeder that incorporates the beneficial features that are not found in competing products on the market.
There are several other products available on the market that fulfill similar purpose. While they tend to have some beneficial functionalities such as voice recording and preset feeding times, it is nearly impossible to come across a pet feeder that incorporates and exceeds these functionalities within one product. Based on the information gathered from market research that was carried out, these are the features that we have seen that our competitors have missed out. Firstly, our competitors have limited amount of stored food, which usually is around 4 to 6 meals. Our competitors offer no confirmation whether the food has been dispensed, consumed, and whom it was consumed by, whether it was your neighbour's cat or it's your cat. Our competitors offer no features to attract the cat once the food has been released, and they use outdated setup methods. They also offer no measurements of amounts of food dispensed and no limitations of amount of food that has been released. Therefore, we took advantage of this opportunity to base the requirements and functionalities of our system by incorporating the features that were neglected by our competitors. Firstly, we use up-to-date human and machine interaction method. Our product is very user-friendly. We offer accurate measurements of food being dispensed. We offer audio playback and capture to attract the pet's attention to come for food once it's dispensed. We offer confirmation of whether the food is consumed or not and how much of it has been consumed. We offer a recall function which recalls the pet several times if the food is not consumed by over a set period of time. The food supplies in our product should last around 1 week, give or take, depending on how much your cat eats. We also offer confirmation of which pet is consuming the food, whether it's your cat or, as previously mentioned, your neighbour's cat, as it can happen. So we use up-to-date technology by emailing the owner and the YouTube link to a video of who has consumed the food.
In order to implement these functionalities, we have produced the following design, which consists of several entities that work together in order to achieve the aim of the system. In order to implement an up-to-date interaction method, we have deployed a web page hosted on the Odroid. The web page can be accessed through any device connected to the same network as the system, which explains why Wi-Fi dongle was used. The web page is used by the user to set the system settings. Another functionality was to implement a method in which we can attract to the feeder upon the release of each meal. This explains why an audio playback and capture device is used, as it allows the owner to record their pet. This voice recording can be played every time a meal is released. An LCD screen was used to display simple information such as time till next feed and the current time. A weight sensor has been used to detect how much food is being released and whether the cat consumed the food or not. These two devices could not have been interfaced directly to the system due to limited I/O available. However, it was possible to use an I/O shield managed by an Atmega processor. Therefore, we have used it to interface the LCD screen through an I2C interface and to the weight sensor through an A to D converter. Communication made to the core processor is made through the serial port. Servo motors are used to control the flap that dispenses meals. The servo motors are controlled through the serial port also. In order to detect whether the correct pet is being fed or not, we have used a camera driven by the motion library. The library allows pictures to be captured each time a motion is detected. An email is sent out to the user each time meals have been released and consumed with a picture of the pet consuming the released food. An email will also be sent out to the user if the pet has not consumed the food after it has been released.
We developed a website for the cat feeder so the user can easily change some settings from the website. The first setting is to set or change the time for each feed. The user can simply add the hours, minutes for the first meal or the second meal, and also can type an email address, so when the motion sensor detects the cat nearby the camera, it will take a photo from the cat and will use it use that email address to send a photo to the owner of the cat. We did this by adding a text area to the web page as an input, and when the text area is filled by the user, it will be saved as a text file format and will be saved on the right directory, well as time for each meal. The other setting on the website is the voice recorder, which lets the user to record his own voice and saves it, so on the feeding times it will be played and will have to call the cat for having its meal.
Thomas, your dinner's ready.
The website has been designed using HTML and CSS for the front end and the JavaScript for the back end development for the most part. The data will be available for the main program using JavaScript variables with using the right functions. The main program will use the email address which user has already provided from the website and will send a photo of the cat to the email address, as well as the short video from the cat while it's having the meal. We use SSMTP command and YouTube API to send the email with the attachment to the user and also upload the video directly from the main program to the YouTube channel. The owner will receive a link for the YouTube video and a photo of the cat at the same time.
Here's the physical design for our smart cat feeder. The housing for this prototype was built from MDF for this design. The LCD character screen will display the current time and the time for the next feed. Here's a demonstration of our cat feeder in use.
Is it this?
Yeah.
Sure.
Thomas, your dinner's ready. Thomas, your dinner's ready. To summarize, some of the technologies that we used were multiple processes implemented in order to initiate and bash interactions, serial port communication to coprocessor, cross-compilation, web servers in order to host a web page, a structured procedural approach in our main program, were used for motion capture, various programming technologies, for example C, C#, JavaScript and HTML were used, and lastly communications with various hardware such as the motors, the cameras, screens were used.
As the product we developed throughout this project was a prototype, we quickly came to realize if more time was given, these features would be implemented into smart cat feeders. Securing the web page by integrating a login method, wet food heating dispensing, 24/7 web availability, tracking remaining food, better image quality, calculation of profitable retail value, object-oriented programming approach to ease maintenance, readability and debugging. Thank you for watching the video presentation of our project. Feel free to ask any questions.